Let's say we're trying to find the derivative of sine x. One way we can go about this is to use our limit expression for a derivative. So we're going to substitute sine x in for our function here. We're going to get something like the limit as h approaches 0, sine x plus h minus sine x all over h. From here, our next step is to use a trig identity on sine x plus h. That's going to look something like this. We'll still have the limit as h approaches 0, and now it'll be of sine x cos h plus cos x sine h minus sine x all over h. We're going to do a little bit of reordering now. I'm going to move this sine x over here, and then with these two next to each other, I'm going to factor out a sine x. So we'll have something like this. The limit as h approaches 0 of this sine x, and the sine x will be factored out to the front. Sine x times cos h minus 1. This minus 1 comes from here when we factored out the sine x in front, plus this part here. Cos x sine h. And you should be able to double check when we distribute this sine x, we're going to get the sine x cos h from here. When we distribute it here, we're going to get the minus sine x that was over here. So I just combined that into one step. From here, we're going to break apart this big fraction into two smaller ones, and we're going to take the limit of both of those fractions. So this is going to be one of them here, and this is going to be one of them here, and they'll both be over h. So we'll have something like this. The limit as h approaches 0 of sine x cos h minus 1 over h plus the limit as h approaches 0 of cos x sine h over h. From here, notice how we have a sine x here in the front that doesn't have an h in it. And when we have a factor without the variable that we're taking the limit of in a limit expression, we can pull it out to the front. Same thing in the second part here, but now it's this cos x that doesn't have an h in it. We can absolutely pull that to the front. So I'm going to rewrite this. We're going to have sine x times the limit as h approaches 0 of cos h minus 1 over h plus cos x times the limit as h approaches 0 of sine h over h. Hopefully this looks a bit familiar. We have two fundamental trig limits, and I have separate videos on each of these going over where they come from. For today though, all we have to know is that this here evaluates to 0, and if you want to, you don't need to look at the proofs. You could plug in a number close to 0 to quickly see that for yourself, but I would recommend looking at the proofs for a more rigorous explanation. This will be equal to 1. So if we're multiplying 0 by sine x, this first part is just going to equal 0. We don't have to worry about that. If this equals 1, it's just going to be 1 times cos x, and our whole thing will boil down to cos x. Therefore, we know the derivative of sine x gives us cos x.